Hello students, in this video I am going to handle the questions asked in 8th January evening of jeemain January 2020 from matrices and determinants. And now this is the question, very simple one. See, A matrix is given like 2294 and we need to identify 10A inverse. And at the end you need to check which option is equivalent with this 10A inverse, right? See, these are the four options given. And this 10A inverse is equals to any one of these four options and we need to identify. See, usually if you calculate A inverse, that's the left hand side part, and the right side again you need to calculate all these differences and then you need to check which of those two are equal. But it is somewhat time taking. So without going with the usual way, calculating A inverse and identifying this difference, I am using the concept of characteristic equation. See, we are all aware about the characteristic equation. See, the characteristic equation for this matrix is given by A minus lambda I is equals to 0, determinant of. So for this matrix, see, A minus lambda I is nothing but 2 minus lambda, 2, 9, and then 4 minus lambda is equals to 0. This determinant gives us the characteristic equation. See, and now, see, this determinant value is nothing but product of these 2 minus this, and then from there we can get it like this. 2 fours is 8, minus 2 lambda minus 4 lambda is minus 6 lambda, plus lambda square minus 9 to 18 is equals to 0. And at the end, if you rearrange, you will get that lambda square minus 6 lambda, 8 minus 18 is how much? Yeah, minus 10 is equals to 0. See, lambda square minus 6 lambda minus 10 is equals to 0 is the characteristic equation of the given matrix. Then by Cayley's theorem, this characteristic equation for sure satisfies the matrix A. So, at the end you have that. Therefore, A square minus 6A minus 10 is equals to 0. See, we need to calculate 10A inverse. First of all, you just rearrange it like this. 10 is equals to A square minus 6A. And now you just multiply everything with A inverse. And now this is equals to 10A inverse is equals to A square A inverse minus 6A A inverse. Multiplying everything with A inverse. So left side is just 10A inverse, whereas right side A square A inverse, 1A together with A inverse becomes identity, and A with identity is A minus this is again 6 identity. So 10A inverse at the end is what? A minus 6I. So this is very simple, just by the support of characteristic equation with the Cayley's theorem. Once again look there, for the given matrix this is the characteristic equation, and on simplification you have this lambda equation. See, by Cayley's theorem you have a chance to replace lambda with A. On replacement this is the matrix equation. If you multiply everything with A inverse, you will get 10A inverse as A minus 6I. So this is the question. One question from this examination, like January 8th evening session, and I will give you another question. First of all, have a look at this. Yeah, now this is the second question from the matrices and determinants, and this question is from the system of equations. So if you observe, all the 6 papers of January 2020 contains one question from the properties of matrices and determinants, and the other question is from the system of linear equations. And now here also in this question I have 3 linear equations, and as per the question, these 3 linear equations have many solutions, unique solution, no solutions depending on the value of lambda. See, we are very familiar, we are very aware about the thing that the system of linear equations in 3 variables have either one solution or infinite solutions or no solution. Okay, and all these things dependent on the determinants of delta, delta 1, delta 2, delta 3. Okay, see, first of all I need to calculate the determinant of delta. Determinant of delta is nothing but the determinant of the coefficient matrix. See, what are the coefficients? Lambda, 2, 2, and then what are the coefficients? 2 lambda, 3, 5, and then the coefficients here are 4 lambda, 6. This is the determinant of the coefficient matrix. If this determinant is not equals to 0, then the system has unique solution. If this determinant is equals to 0, then the system has either infinite solutions or no solutions. First of all, you need to find out this determinant value. See, for that finding, I just make, this is 2 and 2, right? So I just make this is 0, just for simplification. So this is equals to determinant of first row, I won't change, okay? Second row, again I won't change. But whereas for the third row, I do like this: 2 minus 2, uh, 0, 5 minus 3 is 2, and 6 minus lambda. Okay, see, in any way you can do, right? Right. See, and now, see, calculating the determinant of this one is nothing but lambda into determinant of this minus 2 into determinant of this. Okay, yeah. See, here I have 6 minus lambda. This is also somewhat complicated task, so leave it and then just you directly calculate its determinant. Yeah, how can we calculate its determinant? This is equals to lambda times of 6 3 is 18 minus 5 lambda minus 2 times of 2 lambda into 6 is what? 12 lambda minus 20 plus 2 into determinant of this. Okay, 2 lambda square minus 12. Just you try to simplify. See where you have lambda squares first. See, lambda into minus 5 lambda square, right? And here it is 2 into 2 lambda square is 4 lambda square. Minus 5 lambda square plus 4 lambda square will give us minus lambda square, right? Then think about the terms of lambda. This is 18 lambda and this is minus 24 lambda. There is no lambda term there. 18 lambda minus 24 lambda is just what? Minus 6 lambda. Then think about the constant. Here it is no constant, and here minus 2 into minus 20 is plus 40, and then it is minus 24. 40 minus 24 is plus 16, I think so. Okay, so minus lambda square minus 6 lambda plus 16. Okay, see, we need to simplify it. If you come out minus lambda square plus 6 lambda minus 16, so that is equals to minus of, I can write it like this. See, 16 is what? 8 twos, 8 and minus 2, so lambda plus 8 into lambda minus 2. Okay, once again we just think about it. This is equals to lambda plus 8 into, either you may write 2 minus lambda is the determinant of the coefficient matrix. See, once think there, the determinant of the coefficient matrix is lambda plus 8 into 2 minus lambda, usual way. Okay, I am erasing all these things. Okay, if I erase this at the end, the determinant of this coefficient matrix, what we have, this is equals to lambda plus 8 into 2 minus lambda. Right, now think about it. What happens if lambda is equals to 2? This determinant value is 0. Okay, see that question, if you think about it, yeah, unique solution if lambda is equals to minus 8. Okay, so first of all I am thinking about that. If you place minus 8 here, this determinant value will become 0. If the determinant value of the coefficient matrix is 0, then the system has no unique solution, either infinite or no solution. That's why just eliminate this option. Then think about the third option, no solution if lambda is equals to 8. Yeah, if lambda is equals to 8, then this is not equals to 0. Since this is not equals to 0, then for sure it has unique solution, so eliminate this option also. Then if lambda is equals to 2, the first option and the fourth option. If lambda is equals to 2, for sure this determinant is 0, right? Since this determinant is 0, then we have two options, either many solutions or unique solution. Okay, so then our choice may be either option 1 or option 2. Then to decide that, you need to find out any other determinants like delta 1, delta 2 and delta 3. If that delta 1 is again is 0, you will get infinite solutions, or otherwise you will get no solution. Okay, yeah, see at the end what I am going to conclude you is, we need to check whenever lambda is equals to 2. Okay, just leave about this and then you just try to find delta 1. See, what is delta 1 actually? Delta 1 means you just replace x terms with this constants like 5, 8, 10, and y coefficients were 2, 3, lambda, whereas these z terms are 2, 5, 6. And we are going to find out this delta 1 at lambda is equals to 2, because we need to check these two options. At these two options lambda is 2 and for lambda is equals to 2, determinant is always 0. Now leave about the determinant. Think about delta 1. See, if lambda is equals to 2, that in the sense you just replace this lambda with 2. Now you just try to find its determinant value. And if you find its determinant value, for sure you will get it is a non-zero number. Since it is a non-zero number, the system has no solution for lambda is equals to 2. And that's your answer. Okay? So the problem is very simple. See, once if you check, every paper has one question related to the system of linear equations, and easily you can solve that question just by depending on the values of delta, delta 1, delta 2, delta 3. Right? Just have a look. and in the next video I will come up with the questions from 9th January paper, right?